Why? Do you want me to scoot it? Just get a desk up here?
No, don't. Oh, yeah.
Let me see a book or something.
I'm gonna use my book too. I'm not like that. You know you are.
Is it recording though?
It's recording.
Let's make sure we know how to do a problem like this. There's going to be about 10 problems tomorrow like this. Now, these plates have the plasmids. In other words, I'm growing bacteria that should have the plasmid. Does everybody understand? They have been transformed with the plasmid. These three at the bottom are bacteria growing without the plasmid. Is everybody good so far? These two plates have ampicillin plus glucose. These two plates have no ampicillin and glucose. These two plates have lactose only. The plasmid I have has AMP resistance and the lac operon. Is everybody good so far? I'm transforming the plasmid in a bacteria that is sensitive to AMP and has a mutated lac operon. Everybody understand? The bacteria that I'm transforming the plasmid into has a mutated lac operon. And it's sensitive to ampicillin. Is everybody good? I want everybody to consult with each other, take about 2 minutes or 1 minute, and decide which plates will have growth.
Growth of what?
What dear? Okay, this bacteria, if I add ampicillin, he will die.
Oh, plus it do have plasma, and the minus it don't have plasma. The plus it shows growth, and the minus it don't have plasma. You said which one would still show growth?
What are you standing right in front of?
What dear?
What is the bacteria that's sensitive to AMP?
What dear?
What does that have to do with bacteria that's sensitive to AMP?
Because if it sends, I'll put ampicillin here. So the only way he would do is if, yeah, so how would that be?
Oh, here, talk about it later.
How would it get there?
Okay, we can talk all this right.
Oh, so you're saying that all the bacteria,
Delete everything I just
In
said.
these plates have the plasma.
It's like number 6.
Carmichael, give me one plate. Just pick any plate where you'll see growth. Two. Okay? 2 will have growth. Why? Because it has the plasmid. So actually there's no ampicillin here. Anybody can grow. Anybody can grow. But the bottom line is if you have the plasmid, people, you will see growth. Okay, Miller? 1. Again, if you have
Miss
the
Suggs, please
plasmid,
call extension 224. Miss Suggs, please call extension
if you
224.
have the plasmid, people, these 3 plates show the plasmid. Everybody see that? If you have the plasmid, folks will grow. Miss Shackelford? 3. Again, Same token. You have the plasmid, you got the amp resistance, you got the lag outron. Is everybody good? All right, Ms. Darby. 5. Because no plasmid and no ampicillin and no lactose. So he has glucose, so he doesn't need the lac outron. Is everybody clear? There is no ampicillin, so he doesn't need the amp resistance gene. Is everybody clear?
Wait, explain about the lactose or glucose in there.
What, dear?
So there's no glucose in there.
There is glucose, no ampicillin,
But there is
plus glucose. So what does that mean? He doesn't need the amp resistance gene. He doesn't need the lac outron.
Okay.
So he's fine.
He'll still grow.
Is there any other place? No. No growth here. Why? Because you got the ampicillin. No plasmid, no growth. Over here, you have only lactose. What does that mean? You need the what? The lac outron. So no plasmid, no lac outron. Yo.
Will we need to know about long growth, where
No,
like all the
no,
bacteria?
no. Is everybody comfortable with this? Any questions? Is everybody comfortable? Again, if you have the plasmid, don't even blink. Everything would grow. Okay. Gel electrophoresis. Can everybody call it? So if I had like this, can everybody call it? Okay? Everybody understand how gel electrophoresis works? Small fragments to the bottom to the 3' end. 3' end, smaller fragments. And those because of the charge. You can also separate proteins, and if you need to separate the closed spans, you got to alter the density of the gels. Is everybody good? Okay? Does everybody understand if I cut a plasmid? You have a plasmid like so. And the whole thing is 1,000 bases. How would it look like on a gel if I cut it? Let's say this is echo on one side, echo on one side. How would it look like on a gel?
the smallest would be down here.
Okay, what big? How big?
100.
100. And then?
200. 200.
200. Where you get the 200 from?
The 100.
I'm cutting here. I'm cutting here.
Yeah, so we're the ones that were extra.
Am I cutting here? No. This is just my marker where I'm starting. I'm cutting here, cutting here. Shh. How many pieces would I get, people? 2. This is a piece right here. That's 100 bases. What's my other piece? All this. How much is that? 900. So this would be way up here. Just 2 lines. Is everybody clear? I'm getting worried. You got a couple of problems like this tomorrow. The 1 is simply about where am I starting to count. So that's not a cutting site. Is everybody clear on this? Yes, ma'am.
Is that the only thing we'll have to know for that, like the starting and how much?
Well, depending on where I cut, like how big the pieces are, and if you understand that, you're fine.
Okay. Whatever.
Okay? Is everybody good?
I had to say it before you said it. I said it before you said it. You are ugly, but you are the ugly.
So again, guys, the main thing as far as the essays go is this, the DNA gel, this one, and can y'all find me the seed, find me the copy DNA and the original gene given that Sanger method. That's a biggie on my essay. Okay, I'll expect you to draw it and read it. Give me the copy, give me the genome. Is everybody good on that? Okay, that's 3 questions. Okay. RFOP analysis. So let's go through the steps very, very quickly. First you would isolate the DNA, then what would you do? PCR, that is amplify the DNA. Because if I get a vaginal swab, there's not enough DNA. You all understand? I would have to amplify the DNA. Yo,
And that's when you use that machine that like heats it.
PCR, yeah.
Okay.
So the strands, 95 degrees centigrade, the strands would come apart. I would have 2 primers. One would go here, one would go here. So both are leading strands. Then I would put in DNA polymerase, ACGT. So I'm copying. That's at 37 degrees. Then they denature again. Boom. Then I come down. So primer, extend. Everybody good? That's PCR. All right. Then what would I do is then what?
Cut the DNA.
Cut it with a restriction enzyme.
Restriction.
Then what?
Separate the
Separate
gel
it
by the
in
size.
DNA gel. And then you would match. Everybody know how to match the bands? Like who's the daddy? Everybody good on that? Justin?
What you trying to say? I know who my daddy is.
Oh yeah, sure.
No.
Anytime, sweetie, hush people. Anytime you do a forensics type case, custody case, you would have to amplify the short tandem repeat, STR region. Why? Because it's polymorphic. If I amplify the histone gene, for who's the daddy? Everybody's your daddy. Okay. Everybody clear? Is everybody clear on that? Because the gene is the same. All right?
What? You heard it. You heard it.
Hey, last thing, people, then we're going to cut loose.
I need to.
Daddy 1, daddy 2, mom, kid. Okay. When you do who's the daddy, people, listen to me. When you do who's the daddy, the bands have to match either mom or dad. Is that clear? Either or. When you do a crime scene, it has to be exact. Do y'all see the difference?
So for DNA,
DNA.
for like, who's the daddy?
Uh-huh.
Like for this is not the crime scene one.
Maybe.
It's a question.
Maybe. This is a who's the daddy. I got daddy 1, daddy 2, mom, and kid. Who's the daddy? Daddy 1. Daddy 1. Contestant 1, yes, okay. Because the kid's DNA, people, has to match either mom or dad.
He matched it one time.
Now this one matched everybody, so that doesn't matter. Is everybody clear? Kid cannot have it. Let's say the kid had one more band here. Who's the daddy? Neither of them. Every band has to match, mom or dad. If you're doing a crime scene, the match has to be exact. So if this was a crime scene, and let's say this is the vaginal swab, it has to be an exact match for me to call the suspect. Is everybody clear?
Alexis?
Because a vaginal swab is not either or. Is everybody good? Feel good? Good. Bye. Hey, People.
Oh, you bothered.
Can we get your names down, please? Good.